So, this was from last year's paper, 2019, and that was the last question that the students faced. You must be like, Watcher, I never take physics lah, I don't understand this. This is like physics, I don't understand this diagram at all. So yeah, okay, I can understand why you feel that way because this diagram looks very intimidating and it's like, wow, 3D vectors is never easy. So let's just keep calm, just try to analyze this and think about this calmly, think about it step by step, and you realize this isn't actually that difficult. Okay, so you start off, the ray of light passes from air into material. This is a prism, so they didn't use any technical terms here, so you can't say they're referring to physics, okay? They didn't say refraction anywhere. So anyway, the ray of light is sent in this direction. So this is the direction vector that they are talking about. Okay, this direction vector, -2, -3, -6. Okay, this is the direction vector, and it's from this point P. So it's projected from this point P in these coordinates, and it reaches this point Q here. Okay, then let's just try to analyze the questions a bit more. The prism is placed so the ray of light passes through the prism, reaching a point Q and emerging at point R. It's picked up by a sensor with coordinates this. Okay, this is a known coordinate that they tell you, and the acute angle is theta. It's on the top over here, and another acute angle is beta over here. Okay, so it's all with respect to this line, imaginary line called the normal. So don't really have to be so worried what exactly that is. The next part of the information here is also very important. The top of the prism is part of the plane x plus y plus z equals to 1, which means they are actually referring to this part. This is known as the top of the prism, okay? So this is our equation, x plus y plus z equals to 1. This is the entire plane, okay? So, at the risk of making this a bit more complicated, so, just this entire plane is this one, okay? Then let's go down a bit more. The base of the prism, x plus y plus z equals to -9. And it's also given that the ray of light along PQ is parallel to the ray of light along RS, such that PQ, R, and S lie on the same plane. So if I tell you PQ is parallel to RS, PQ parallel to RS, right? It means this RS will also have the same direction vector, -2, -3, -6. Okay, that's how we analyze this question. And of course, finally, there is this bottom, what do they call it? Base of the prism, yeah? So I'm just going to shade this a little bit. This is like the base of the prism, okay? Base of the prism. So equation so I realize this luminous green might be a bit hard to read. So maybe next time I won't use this on a white background. So yes, okay, fine. So that's all the information that the question gave us, and we've already filled in the diagram and explained it. So now we need to move into the questions. So now they want the exact coordinates of Q and R. So you might say, wow, how do I even begin? But just think about it calmly for a while. This point P, and you have this direction vector, -2, -3, -6. That means we can find the the vector equation. So how I'm going to do this, I'm just going to write down the equation of the line. Okay, vector equation. So equation of line passing through. I try to write a bit more quickly so that the video doesn't have to be too long. Because if I explain this question is going to take quite a while actually. So let me just be quick. So you have this line equation, right? General point R equals to the known point 224, which is P, right? Plus lambda, the direction vector we have here. And lambda is a real number, okay? So Q, right? Since Q lie on this line, we can write down something simple. And we say OQ is equals to, just like this, 2 minus 3. Sorry, this should be a 2 here. 2 minus 2 lambda, 2 minus 3 lambda, 4 minus 6 lambda. And then for some lambda which we don't know now, which we will find out later. So then you know from the diagram, right, we already said Q is on this prism. So Q must satisfy this Cartesian equation. So you know for vectors, the plane, right? By now at this stage of A levels, you shouldn't have problems converting the Cartesian into the vector normal form, right? So I'm going to say since Q is on the prism with equation R equals to, R dot, the normal vector, which we are given. Sorry, we're not really given, but you need to know how to convert this. Because let me just spend a bit of time on this, right? X plus Y plus Z equals to 1. What does this mean? So this X here, right, the coefficient is 1. It's here. This coefficient Y, it's here. And this coefficient Z is here. And then the 1 you see there, it's this one. Okay? So since Q lies on this, right? So Q must also satisfy this equation. So this general point R I replace with the Q, and it must satisfy this equation. So I'm going to put in this. So OQ, you can do the substitution on your own, right? 2 minus 2 lambda, blah, 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 4 minus 6 lambda, dot 1, 1, 1 equals to 1, right? So by now, basic arithmetic, you guys shouldn't have a problem. So I'm going to skip some steps here. So finally, you end up with 8 minus 11 lambda, is it? Okay, equals to 1. And then lambda is 7 over 11. Therefore, right, OQ will be, you put in the 7 over 11, right? And then we factorize out 1 over 11. 8, 1, 2. But this is not good enough. The question wanted exact coordinates of Q. So we're going to write down coordinates of Q to satisfy what the question wants. Coordinates of Q goes to 8 over 11, 1 over 11, 2 over 11. These are the coordinates of Q. Okay? So then, right, we can do something similar for the other point that we need, which really means we are finding another line equation, vector equation for this line RS, and then we're going to dot to the base of the prism this Cartesian equation, repeat the same thing, and we are going to get the coordinates of Q, of R over here, this one. So again, let's just try to do this. So blah, blah, blah. I'm going to skip all the writing of the words, because this is how I present my answers. So that's my recommended way of presenting. So for you guys, right, just continue writing the words, and then you should end up with this R equals to -5, -6, -7, the known coordinates of coordinates S, plus this mu, this direction vector, is a real number. And then, so OR, right, because OR we know lies on this line. So we're going to get this one. Okay. If any part is unclear, you could just review the couple of minutes before this, and then it shouldn't be too hard to understand because it's just a repetition of the skills that you applied just now. Okay. For some real mu. Okay, and then again, since this R is on the base of the prism, so now, but the vector normal form is 1, 1, 1 equals to negative 9. So this is different from the one you had on top because it's simply a different plane you're talking about. So they have the same normal vector though. Okay, so then you're going to repeat this process. So you substitute in this entire thing into this, then you do the dot product correctly, then blah blah blah. You're going to get negative 18 minus 11 mu equals to negative 9. Mu would give us, we end up with mu as negative 9 over 11. Okay? So, sorry, OR, right, would be after we substitute, after I factorize the negative 11, negative 1 over 11, negative 30, positive 37, 39, and 23, which means coordinates of R equals to negative 37 over 11, negative 39 over 11, and negative 23 over 11. I know these numbers look ugly, you know, it's like, you know, some weird fraction and so on, but they wanted exact, so, you know, just give it to them. All right, so now this one, 5 marks, we are done. See, that wasn't too hard, right? I mean, it took a while because I was explaining this at the same time as trying to write it out. So this is done. Okay. Then, right, let's try to do part 2. Okay, sorry, I can't switch colors again. It's something to do with my OneNote. If there's any OneNote gurus out there, please tell me how I can get out of this conundrum. Okay, anyway, so cosine theta and cosine beta. So just to recap, theta is over here, right? So now you think about this. This is a direction vector negative 2, negative 3, negative 6. And then you know this normal vector is 1, 1, 1. So if you want to find the cosine of the acute angle between two vectors, right? What do? You simply mod them together. What do I mean? Again, cosine theta just means you simply mod the two vectors together. Sorry, you dot the two vectors together. Dot 1, 1, 1. Magnitude of this divided by square root of the individual magnitudes. So 2 square plus 3 square plus 6 square gives us root 49. This root 3. Okay, so again, at this stage of A-levels, when you're practicing actual papers, right, you shouldn't have much problems with figuring out what we are doing here. This is just the angle, acute angle between two vectors. The two vectors here are 1, 1, 1 and negative 2, negative 3, negative 6. Because I'm just trying to work out the problems here, this is not a comprehensive revision. So next time, if we have the chance to have a tuition session together, I'll go through the revision in a lot greater detail. So the arithmetic here, blah, 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 you guys can handle it, right? So 11 square root 3 over 21, okay? This is the third form. But of course, they didn't request for 3 significant figures. You could have written something, 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 then 3 significant figures, that's perfectly fine, okay? That's perfectly fine. But for me, I just prefer to leave it in the third form. Okay. Then, right. So then the next part, we want to find cosine beta. So again, right, it's the same process. What do I mean there? See, beta, right, is between this vector and this vector lah, QR. QR is pointing like that. So for just now, just for completeness, right, just now when you have the direction vector -2, -3, -6, right, this normal vector is pointing out like that. So remember, normal vector always point out from the plane. So if we define this like this, right, the top of the plane, we define this outside like this. So when you want to dot these two vectors, this one is still 1, 1, 1. And then this one will just, this vector here, right, is QR, which we need to find. So because we've already found the coordinates of both R and Q, right? So if I want to find QR, it's OR minus OQ, isn't it? So again, blah, 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 the arithmetic. You should get -5/11, 985. Okay? You should get that too. And then, right, if you want to move on, so now again, repeat the same process. Okay? Cosine beta is equals to modulus of this 985 and the normal vector 1, 1, 1 magnitude divided by the magnitudes of this individual. So this 170 and square root 3. Your final answer will be, let's see, 22 square root 510 over 510, which if you really want to be specific, 11 square root 510 over 200 and what's that? 55, yes. Okay. Again, three significant figures answer will be fine, but it's up to you. So again, these 3 marks, we are done. Okay. Now, part 3 might be a bit tough also, but not too difficult also lah. Find the thickness of the prism measured in the direction of the normal at Q. So in the direction of the normal at Q, right? So direction of the normal here, which we've established, right, is actually pointing out of the plane like that. So if you look at the thickness of the prism, right, we are actually looking for, this is the thickness we're talking about. Okay? So what's the thickness here? It doesn't look so friendly, right? Like, what? Wow, how did you how to find? So, but just be a bit calm here, right? You see, this is the vector 1, 1, 1, right? And now you want to find the length of this vector. So how do you picture this length of this vector? You realize this QR, right? You imagine now you are projecting this vector QR onto this 1, 1, 1. And then we are finding the length of projection of QR on 1, 1, 1. Correct? Length of projection of this one, because this one will be a right angle, right? So the length of projection of this vector QR onto 1, 1, 1. So you see this thickness thing, right, is like disguised in a way that you need to understand what they're asking you. Because when you learn in school, right, in your JCs and MI, so they'll tell you that, oh, length of projection of vector A onto vector B. But this question doesn't say that, you see. They tell you to find the thickness of the prism. So, then you need to see, okay, this is something I know, right? This is the length of projection of QR onto the normal vector 1, 1, 1. So now that we know this, right, it's not so intimidating anymore. Okay? Part 3. So essentially, right, what we are doing, the thickness of prism, right? is the length of projection. So how do we do the length of projection? QR dot 111, okay? Because you're projecting, it's the length of projection of QR onto 111 divided by the magnitude of 111 lah, square root 3. Okay, all these formulas, at this stage of your A-levels, your revision, you should be comfortable with quoting this straight away. So QR dot 111, again QR we found is negative 5 over 11, 985, right? So we dot 111 divided by square root 3, we mod it, blah blah blah. I'm not going to do this for you, you can do it on your own. 10 square root 3 over 3, the exact answer. So again, 10 square root 3 divided by 3. They didn't give units, right? So I just write down units. Three significant figures answer would be fine too. So you see how we decomposed the question? It's like, it's written in a way that, wow, I don't know how to do. But if you just think about it calmly, right, actually it's not that difficult. So this part we're done too. See, 335, we've already gotten 11 marks in our bag. Okay, so now coming back to this, right, it's like, now is the part where, talk about the physics lah, but, it's not so intimidating. Because they just tell you that, okay, there is this law, this guy Snell who said sine theta equals to k sine beta, where k is a constant called the refractive index. Find k for the material of this prism, and actually it's only 1 mark, so we shouldn't spend that much time on it. So again, let me just be a bit quicker here. Don't take up too much of your time. So part 4, right? So if you rearrange this, k will be equal to sine theta over sine beta, which will be equals to, so actually previously we already know the value of cos theta and cos beta, right? So you cosine inverse them, find the acute angle, and sub into this sine theta and sine beta. You shouldn't have any problems, 1.86, 1 mark. That's it. Okay? That's really how simple it is. They didn't ask you to interpret or anything. Now, the next part, right? Part 5, then they ask you to interpret something. So what do they want you to say leh? Because we know that theta and beta are both acute. Okay? Theta is the acute angle and beta is also acute angle. So we need to write down something, this relationship. They are both between and pi over 2. Okay? But which is bigger now? They told you that what happens if beta is bigger than theta. Okay. So maybe like this now. That's how I picture it. Beta is bigger than theta, but both of them will always be between 0 and pi over 2, acute angle. So because you think about this, right? Because they are both within 90 degrees, right? So you remember your beloved sine graph, like this, like this. This one we are in the first quadrant, right? This one is pi over 2, correct? This is x, this is y. So then you think, okay, so if you have this value beta bigger than theta, right? So the value of the sine will be larger also lah. Means sine beta will also be greater than sine theta. Okay, because of this lah. If the x value is larger, that means within the first quadrant, right, the sine value is also larger lah. So 0 sine theta sine beta. Okay. So then, right, what can be said about k, the refractive index? So let's divide everybody by sine beta. Okay, because we know at the end of the day, k is sine theta over sine beta. So we need to get something that has sine theta over sine beta. this is like how we do proving last time, right? You try to move towards what they want you to show. So then we see sine theta over sine beta already. So this is actually k. Ta-da! So you see, what can be said about the value of k for material for which beta greater than theta? That's all we need to write. K is between 0 and 1. Okay? That's it. That's how I wouldn't say this question is simple, because the interpretation of this question isn't that simple. And also when they want to give you this diagram, right, it's actually to help you. But no matter how they orientate this diagram, right, some students will just get confused. Some people will just be so worried because of the time pressure. This is the last question of the paper, and then they'll just freeze there and just waste their time. So I'm just saying, right, if you encounter such a problem, whether in your school prelim or the actual A levels next time, right, don't panic. Break it up into pieces that you know how to solve. Okay? So now that's the end of my video. So if this video helped you, please like and subscribe and tell all your friends about this channel.